Now let's go ahead and button up these conductors with some zip ties. Just start getting things looking a little cleaner, a little nicer as we move forward in our installation process. So we're just labeling some of the core conductors before switching to using an air saw to cut out a portion of the floor for the pathway for our conductors to go from under the center line of the floor and around the corner and over into our electrical box where they will get patched in. So that's looking great. Air saw worked really well for this application, much easier than cutting metal, particularly with the smaller pancake compressor. So now that we got our conductors over, we will patch them in, get the 6 AWG conductor from the starter battery connected to this charge controller. So I wish I would have just made it a little bit longer when I ran it rough, so I wouldn't have to patch it in, but that's what I did. These are the ferrules on the conductors that are going to go into the DC to DC charge controller, and ferrules are a good thing, so just do that. Okay, now we're going to the front end of the vehicle to expose the house battery, where we will make our DC to DC connection from this 6 gauge conductor. Additionally, we are going to put a 60 amp breaker following the specs in the DC to DC charger manual right here where I can reach it from the cockpit, which is nice because I can manually turn off this breaker or manually reset it very easily. So we're just putting the positive lug there, and the negative one goes straight home to the negative. This took some time to run, but we got it done with the crimped on ferrules, or sorry, gosh, I can't remember what those called. Let's just call them connectors that have eye loops in them. All this stuff goes directly to the battery. We already said that. And it looks good and feels good, and we're ready to test once it's all in. One thing I'll note is that having a pull string for any conductors you run under your floor is helpful, just in case you need to pull one in the future. That's what that green line is. And it's also helpful to add any additional sound insulation. You can see a lot of factory sound dampening material on the existing floor, but there's none on top of the battery box. So I actually ended up putting some on later outside of this video, which you'll see in the future. But if you got some, just do it then. Here's our final product. Just pointing out the runs under this cover and then back in under the subfloor. And there's a better view of the specific AC breaker on the home battery side. Links to all this stuff are in my Amazon store, so just check there. And now we are ready to test our system. So we got a Bluetooth light on the charger, so let's connect to it on Victron and see what we see. I don't have a power light because I didn't have my on switch on. So plug that guy in there. Now we got the power on. Now, if you're connected to the Orion-Tr Smart controller over your Victron app, you're not going to be able to produce power at the same time. All right, so we've used our phone's selfie camera to take a picture of the puck code because which is printed under here where we can't see it because we can't connect. So we're going to try and reset that. And we will do that by going to our Orion, reset code, and then I got the puck code written here in my manual. So here we go. 382 Charlie Bravo 8 Charlie 358 Bravo 8. Okay, we are rebooting the phone as a troubleshooting step. So once it boots, we'll jump back onto the app and try and connect again. Okay, app is booted, device list is loading. We can see our Orion Smart here, broadcasting. Okay, there goes our connection. 60%, 80. See if it gets past 80. And it does. We get to this pair screen and we type 6 zeros, click OK, and see what happens. Connecting. And we're connected. Yay! Now that we're connected, we are going to do a software update so that our our charge controller has the latest software available from the manufacturer. Okay, just auditing my settings here. Output voltage 12 volts is good. That goes to the house batteries. Input voltage lockout. Sub 12 voltage is good. We don't want input voltage when the voltage is low. That would kill the house battery. Now that the vehicle's running, we're still not seeing any power from the DC system, so we get the multimeter and we test. So we can see we got 15 DC coming in, and we got 13 DC going out. So I figured out what was going on. When I was connected with my phone to the DC to DC charge controller, it wouldn't send power, but we could see the voltages from the power going in and the voltage from the batteries on the multimeter. However, when I disconnected and ran the van, I could see the power coming in. And that's what we can see logged here in this graph of our DC usage. So where we see positive values, the power is coming from the DC system, and when we see negative values, the power is going into the DC system in DC. This happens when the alternator charger is working, and we can see smaller wattages early on, but we peak in the 280s range, and that's typically what the DC to DC charger shows. Now there are some gaps in this data when the system wasn't connected to Wi-Fi. I plan on connecting it to my Starlink while driving to get more consistent data measurements while the system moves, but this data is enough to show that the system works, and we now have a DC to DC charger that is gonna charge the house batteries from the alternator at around 283 watts. In any case, that's all I got for you today. Thanks for watching. We'll see you around.